I'm going to give you some quick, helpful tips for finishing your extension packet, your extensions for the quadratics. For this here, for graphing, you can look quickly at your A values to see if the graphs open upward or downward. So as soon as you see that there's a negative A value, you'll know that the graph is upside down. And then the other thing you'll probably want to look for is just the y-intercept, okay, which is the constant at the end of the equation. That'll tell you where the graph goes through the y-axis, okay? Down for this question here, you need to find your x-intercepts, y-intercepts, vertex, and then graph. Your x-intercepts you find by using the quadratic formula or by factoring. Your y-intercept is always the constant at the end, and your vertex is found by using negative b over 2a. That'll give you the x value of the vertex, and then to find, so that'll give you this. When you want the y value of the vertex, you plug the x value back into the equation and solve for y. Then you're going to graph that information. When you're trying to match these equations up with these graphs, some of the equations aren't as simplified as they could be. Like this one's as simplified as it can get. So you can take this one, look for a y-intercept of 2 in your graph, and look for a graph that opens upward because the a value is 1. But for these ones here, what you need to do is simplify them.
Happy Friday, everyone. The winner of our double pot for 50/50 of $69 is Mr. Mike Flynn. You can come on down to the office and get your cash. Everybody have a wonderful holiday break.
So you have to distribute here, and then you can take this and look for a graph that has a y-intercept of 12 and opens downward. Okay, you'll have to distribute this. For this one, you'll have to square this first. So x minus 2. You can use the box method if you want to multiply the two polynomials. So x times x, x squared, x times negative 2, negative 2 times x, negative 2 times negative 2. Put your like terms together. And then you're going to make everything negative at the end. Make everything negative. So multiply by negative 1. When you're done that, you will subtract 1 from the constant. Negative x squared, positive 4x, negative 4, then subtract 1. So you'll put these guys together. You'll have negative x squared plus 4x minus 5. So you're looking for a y-intercept of negative 5 and an a value of negative 1, provided I did that multiplication quickly and correctly. Factor these quadratic functions as much as possible. So just remember, you need to take out a GCF first, and then you're going to look to see if you can do more factoring using the box method. All right. So you have to, for these, you'll have to do GCF first, then the box method afterwards, and solve for x. So your x-intercepts are when y equals 0. So once you find what x equals, once you find what your factors are for each of these questions, set your factors equal to 0 and solve for x. That's how you get your x-intercepts. An equation that has x-intercepts. Okay, so I know that when I get to here, I need x values, an x value that's negative 5. So one of my factors must be x plus 5, because I have to set this equal to 0. So negative 5, x must be negative 5, because negative 5 plus 5 is 0. Then positive 6, so it must be x. If I want x to be 6, it's going to have to be x minus 6 that equals 0. There's only one root here, so it must mean that we have x plus 2 and x plus 2 as both of our factors. Okay, now if you want the equation, you're going to have to go and multiply this out. So go distribute, you can use your box method. So x plus 5 put your like terms together, okay, and simplify. So you want the final equation would be x squared negative x minus 30. You'll do the same for this one over here. Determine the x-intercepts, y-intercepts, vertex, then graph, same as the other question I just talked about. You'll have to factor or use the quadratic formula. Okay, that'll give you your x-intercepts. Then your y-intercept is just the last number, provided it's in general form like these are. So this one's negative 32 is your y-intercept. To find your vertex, you'll need to do negative b over 2a. Once you get what x equals, you'll plug it back into the equation and solve for y. Then graph. Double check your answers. And then extension applications, so we're already familiar with these. They might just be a little bit harder because they're asking for more detail. You can replace this with y. You can replace your t's with x's. In this case, the c value is 0. And these ones, you're going to have to graph them yourself. Okay, so see how the y-intercept is 0? That means I know that this graph, and it's negative, so it's opening downward, so I know this graph's going to look like this. Okay, because I should have an x-intercept of 0, which is also the y-intercept, because this tells me the y-intercept. In this graph, we're going to be starting at an initial height of 1 meter. Okay, so you're actually going to be doing this kind of a shape. This one you're starting at 40. So this would be starting at 40 right here. Your initial height would be 40. It's an upside down parabola because we have a negative a value. Negative a value starting at 5. Okay, check your answers. These last application questions, there are a couple that you're not responsible for. Any of the questions that ask for maximizing profit, we don't need to do. So you don't need to do this one. You should be able to do example 1. Okay, example 2, you can skip. The profit questions you don't need to do. You can do this one. That one's fine. Revenue, don't do this one. Okay, so do this one. Don't do 1. You can do 2 and 3. 4, don't do. You can do this. It's just going to be a harder question. You don't need to do that one. You can do this. It's just going to be harder. And the last question, you could do that one. All right. The ones that I X'd off, you don't have to worry about. They will be on the extensions test. Let me know if you have any questions. You can email me with specific questions that you might have. It might take me a while to get back to you.